All right, so 4.7 is all about how to solve quadratics when we can't factor it and it's not already set up for the inverse method. So complete the square will allow us to solve unfactorable quadratics using the inverse method from 4.5 and 4.6 because we could have imaginary solutions. So complete the square. This is what we know so far as solving equations. So solving equations, we know method 1 is to factor. And we know how to factor greatest common factor, like x squared plus x equals 0. That's going to be x times x plus 1 equals 0. And then we have two tiny equations, x equals 0, x plus 1 equals 0, and we solve from there. So greatest common factor. We know also how to factor a trinomial, like x squared plus 5x plus 6, where we would factor it into x plus 3 times x plus 2 equals 0. The zero product rule says that we can take each of those and set up a tiny equation, x plus 3 equals 0, x plus 2 equals 0, and solve from there. So we know how to factor. The rule for that is that we're going to set it equal to 0 in order to factor it because we're using the zero product rule. So set equal to 0, use zero product rule, which says we can make these tiny equations. 2, we know we can use the inverse method, which is to take the square root of both sides and put plus or minus so that we get two answers. It's hard to see the minus there, but it's there. So the inverse method undoes x squared because we take the square root of both sides. Okay, and I haven't read in my description over here, solution must include plus or minus. So the inverse method. An example there would be something interesting. How about x plus 4 all squared equals -3? This would not factor. I know it won't factor because I made it up to not factor. I made it up so that the square root on this side is not something that's a rational number, not something that's like 4 or 3. The square root of this is going to stay inside the square root and be an irrational number. So if I take the square root of both sides and add plus or minus in there, x plus 4 is free of the square. I have plus or minus I for the negative, and the square root of 3 stays inside, and this solution looks like -4. We move this over, plus or minus I square root of 3. So the inverse method is not set equal to 0, and its method or its way to spot, you can spot this method because you have x squared. It could be x squared, it could be x plus 4 squared, it could be x minus 2 squared. As long as the x is under square and there's not an x term, then you can use the square root on each side. But what do we do when there is an x term? How do we solve any equation? So these are two methods to use in certain circumstances, but if it doesn't factor, if it has an answer like this, there's no way you're going to make a list that includes a square root of 3 in it when you're trying to factor. What if it's some answer like this, but it's not ready to go? So this is a formula. If it's not in this formula, we're going to have to turn it into that formula. And so today we're going to learn method 3, which is called complete the square. And that goal is to have something like x plus 4 all squared equals a number. We're trying to get a square. Complete the square. We need a square. So I want to explain why we're doing what we're doing, and then we're going to learn how to do it. We're going to start with x plus 4 squared. We're going to look at how to complete the square from a finished product side first and understand what that means. So I'm going to show you visually what x plus 4 squared means. I think when we were talking about these rules that I mentioned that the term quadratic, which is what all of our squared things are, like up here, x squared plus x, having a square and being called a quadratic means that we have a quadrilateral. We have two sides. We're finding area of it. So what does this mean in an area model? So an area model would look like this. We would have x plus 4 as a side of a quadrilateral. So I'm going to call this piece x, and then I'm going to say that I have up to here, and I'm going to add 4 to it. So 1, 2, 3, 4 little tick marks there. On the other side, I have the same thing. I have x, and then I have 1, 2, 3, 4. And you'll see what I mean by that in a second, but I've got x plus 4. So this is the length of this side. I don't know how big x is, but I know that if I'm doing area, the area of this, well, I'm not going to put the squared there. I'll leave it over here. X plus 4 times x plus 4 would be x plus 4 times x plus 4 written out, which is x squared plus 4x plus 4x plus 16, x squared plus 8x plus 16, if I'm just looking at the pure algebra of it and multiply it out, x squared plus 8x plus 16. But let's look at the area model. The area model says that if I multiply part of the side by the other side, this piece of x length times x length is x squared, and it's the area of a square. Then I'm going to say I've got 4 pieces, which are each 1. So there's 1, 1, 1, 1. 1 times x, so this side times this side is x. And each of these long pieces are 1 times x, or 4x. If I add them together, x plus x plus x plus x is 4x. I'm going to have the same thing over here. I've got 1 on this side, and if I do the x, same distance here, so 1 times x, this side is x. I have x, x, x. I have 4 x's here as well. So far, in the area model, I have x squared, and I have 4x here and 4x here. That's 8x. And then what I should have right here, and this little extra little part, is how you would have done this in 5th grade or 3rd grade or when you learn to multiply. This is 1 times 1. Each of these blocks is a 1, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 little squares there. So if you look at it as an area model, I have x squared plus 4x plus 4x plus 16 individual pieces. Okay? Notice that if it's a square, some specific things have to happen. Each side has to be equal. So if one side is x plus 4, the other side has to be x plus 4 for it to be a square. And this is squared. See the square here? It means they have to be exactly the same. What does that mean? Well, that means that if this is 8x, then if I have two sides that are the same, they have to be half that much. So one side has to be 4 and the other side has to be 4. That's how you get 8, half of that. Also notice that this, when you multiply it out, we named it the other day a perfect square trinomial. And we named it the other day. We could have used other factoring methods to get there, but we named it the other day because we're going to use it now when we're completing the square. It's named completing the square because we're using this perfect square trinomial every time. So hopefully you may not see the connections yet, but hopefully as we start doing these, some of you may really appreciate the physical notation of what it means to be something squared in the area model. Some of you will just understand the math and follow it with a few examples. Some of you may need both, and some of you may need a whole extra day of practice to complete the square. But you need to let me know how much extra you need to follow this. To be a perfect square trinomial, and I've written out a quadratic here, ax squared plus bx plus c, we're going to have these goals every time. Well, first goal is to have a equal to 1, if we can do that. So a equal to 1. We might have to divide out and get some fractions so we can have a equal to 1. So we'll do those, but we're not going to start with those. We're going to start with a equal to 1 when we work our problems. Second thing, we need our b in the factored version. So when we go to factor it, goals, a equals 1. Goal number 2 is going to be that the factored form includes x plus or minus, I don't know, it depends on what b is, b over 2. Okay? And that's because if the sides are going to be the same, if this number is 8, this has to be 4 and 4. The sides have to be the same, and the same number has to add up to 8. So it has to be the middle number divided by 2. 8 divided by 2 is 4. So right here in this factored form, it's going to be b over 2. Lastly, c is b over 2 squared. This is the square part. Okay? So if you take this 8 and divide it by 2, you get 4. That's these two sides. And 4 times 4 makes 16. So the number in here, you divide by 2, we're going to multiply it out to get 16. Let's do some examples, but I wanted you to have these goals so you can go back and look at it when we're trying to complete the square. Let's do some problems. First, we're going to find the c value. So let's say that we have to begin with, in example 1, let's say we have just the expression x squared minus 6x plus, and I don't know what goes here. So we're trying to complete the square. And my goals on the other page said that I'm going to try here to have x, and I'm going to put the b value, -6, and divide it by 2, and that's going to be -3. So it takes on the same sign as this value, and then to get back here, I'm going to take -3 and square it. -3 times -3 is 9. Does that work? Let's check. X minus 3 times x minus 3 is x squared minus 3x plus 9, and that works. That gives me x squared minus 6x plus 9. So this is the first part of complete the square, is figure out what c is that would make this a perfect square trinomial. So now x squared minus 6x plus 9 is a perfect square trinomial. It wasn't in the beginning. When I started the example, it was x squared minus 6x without the 9. It wasn't a perfect square trinomial, it was a binomial. We turned it in by adding 9 to it. So we completed the square. And I keep saying that until maybe it makes sense. Example 2, x squared plus 14x plus, I don't know what goes here. So every time we're going to start with x, and we're going to find b over 2 to put here. b is 14. 14 over 2 is 7. It's positive 7. x plus 7 squared. X plus 7 squared multiplied out is going to be a trinomial. So it's going to have x plus 7 times x plus 7, again, x squared plus 7x plus 49. You take this number and you square it. So you take half here and then you square it and put it here, 49. So 49 is the C value of the perfect square trinomial. So let's do see if we can do them a little bit faster. So here we go. X squared plus 8x. The value for C is going to be 8 over 2 equals 4 squared is 16. That's the C value. B, x squared minus 16x. What goes here to make it a perfect square trinomial? 16 divided by 2 is 8. It's actually negative 8. Negative 8 squared is going to be 64. Notice how whatever you put in this box that completes the square, I put it in a box to make it look like a square, is always positive. Because when you square negative 8 squared is positive. Positive 4 squared is positive. Anything you square is always positive. C value in a perfect square trinomial will be positive. Always. C, x squared plus 20x. What goes here? 100. It's going to be x plus 10 times x plus 10. That is x plus 10 squared. D, x squared plus, I don't know, 32x. What goes here? This is going to be 16. This is going to be 16 squared. I don't even know what that is. So 16 squared goes here. Half and then square every time. This is going to be written now, since I've added the 16, as x plus 16 squared. So hopefully by now, you're really a little bit more familiar with the complete the square part, which puts the half here. We're doing b over 2 for the factored part. That's this. And then we're saying b over 2 squared for the c value. All right, so we've practiced that a little bit. Complete the square. Let's see how we can use that to solve equations. All right, example 3. This one's almost ready to go. We're going to solve x squared plus 6x plus 9 equals 36. We're not going to solve it by factoring, so we're not going to make this equal to 0 and move the 36 over. We're not going to solve it by taking the square root of both sides, not yet, because we have this x term, so that messes us up. So this needs to be rewritten in a way that we can take the inverse. So this is a perfect square trinomial. X plus 3 times x plus 3 makes x squared plus 6x plus 9. So let's write it like this first. I think for some students that's really helpful. You could check it. Half of 6 is 3. That's what we were just doing. 3 times 3 is 9. 3 squared is 9. So that really looks like x plus 3 all squared equals 36. Now we have the inverse method will work because we have x under the square. We don't have a term that just has x in it like this anymore. We've rewritten it in a form we can use the inverse for. So now we're going to use the inverse operation. We're going to take the square root of both sides. Part of taking the square root of both sides is we're going to use plus or minus. So the square root of this, plus or minus. That gives me x plus 3. Square and square root cancel. Plus or minus the square root of 36 is 6. I'm going to subtract 3 from both sides and say x equals negative 3 plus or minus 6. What does that mean? That means negative 3 plus 6. Plus or minus means here's the plus, or negative 3 minus 6. So my x values are negative 3 plus 6 is 3. Negative 3 minus 6 is negative 9. These are the two values that make this a true situation. If I plug them in, I will get 36 equals 36, either by plugging in 3 or negative 9. Let's do another like that. So this will be example 4. Example 4 says x squared minus 10x plus 25 equals 1. This one's almost ready to go. This is a perfect square trinomial already. My b term is negative 10. Half of that is 5. So negative 10 divided by 2 is negative 5 squared. That's the factorization of the perfect square trinomial equals 1. Square root, x minus 5 equals plus or minus 1. Add 5 to both sides. X equals 5 plus 1, 5 minus 1, x equals 6 or 4. Those are the answers that work there. Example 5. Pause these and watch them slower if you're not following. This one's not going to work out so pretty. Let's see. X squared minus 10x plus 25, so the same part there, that it's going to be equal to 3. So to solve this, this is a problem that if it had been written another way, this would not factor. If I move the 3 over and got 22 over here, then I'm not going to be able to factor it. Factors of 22 don't add up to be 10 because they're going to be the same sign. So here we go. X minus 5 squared is how you factor the perfect square trinomial equals 3. So I haven't done anything. I've just rewritten this in another form so that I can use the inverse, square root of both sides, plus or minus. Square and square root cancel. Negative 5, x minus 5 equals plus or minus the square root of 3. The square root of 3 does not simplify, so it's going to stay inside the square root house. I'm going to add 5 to both sides. X equals 5 plus or minus the square root of 3. It's really important that the plus or minus stay with the square root of 3. Now, this is a decimal number. It's some approximation. I would be able to see it on a graph if I graph this parabola. This is what the calculator would tell me the intersection of this parabola and 3 is. But this would not be something I could factor. It's not 6 and 4. This one would have factored if we'd have rewritten it another way. So this problem, if we had rewritten it as x squared minus 10x and subtracted 1, so we had plus 24, equals 0. Now it equals 0. We can factor it. It would be the same sign because of the plus and the minus, and 6 and 4 make 10. Well, I need an x there. So this one would have factored, and I would have gotten x equals 6 and 4. 6 plus 4 makes 10. 6 times 4 makes 24. But this one, there's no way. You're never going to think of 5 plus the square root of 3 as a factorization. So we need complete the square for our equations that don't factor. That's how we're able to solve any equation. All right, so these examples, the last 3 examples, have been set up, ready to go. So by ready to go, I mean this was already a perfect square trinomial. They're not usually like that. So what we need to do in example 6 is figure out how to set it up so that it is ready to go. So this is the part that's to complete the square. This was ready, oops. This is complete. It has a B and it has a C, that is the square. Let's look here at example 6. I'm going to have x squared. So I've got x squared plus 14x plus 2 equals 0. So you would probably agree with me pretty quickly that factors of 2, 1 and 2, do not add up to be 14. So this does not factor as it's written right now. It doesn't factor. So what I need to do is rewrite it in a way that I can use the inverse operation, which I'm going to need complete the square. So this is going to be our first example of really the steps in complete the square. So number 1, notice it does not factor. Or the directions say complete the square. One or the other. 2, you need to move the C value that you have to the right-hand side. So RHS means right-hand side. So 2 is what messes me up. If I had a different number here, maybe it would factor. But 2 doesn't help me factor, so I need to move it to the other side. And I'm going to do that, x squared plus 14x. I'm going to leave a space, and I'm going to put negative 2 on the other side. So when I move positive 2 to the other side, it changes signs. And I'm going to leave a space here because what I want to do is that I want to complete the square. I'm going to find the C value that completes the square here. And we've done that on the other pages of notes, but I'm going to add a square to both sides. You remember that in equations, if you do something to the left-hand side, you have to do the exact same thing to the right-hand side. So in order for me to move this 2 to the other side, I subtracted 2 from both sides. And so that canceled on the left-hand side and left me with negative 2 on the right-hand side. So I need to complete the square on the left-hand side. We've done this. It is x plus 7. Half of 14 is 7. I put a square there. This is b over 2 equals 7, and I put it here. In this box goes 7 squared. So it goes back up here as 49. Remember, that's always positive. If I decide to fix my equation by adding 49 to the left-hand side, that means I must also add 49 to the right-hand side. Now I have x plus 7 squared equals 47. Now it's ready for the inverse function. So take the square root of both sides. So I'm going to write it again so it's pretty. X plus 7 squared equals 47. Now I have x under a square. I can take the square root of the left, the square root of the right, add plus or minus. Simplify, x plus 7 equals plus or minus the square root of 47. 47 is not divisible by 3. There are no squares in 47. It doesn't simplify any further than it is. So this is an irrational answer. It's a decimal, and I could find out what it is, but it's not something I could factor. Remember, it wasn't factorable. So I'm going to move the 7 to the other side and say x equals negative 7 plus or minus the square root of 47. So what did we do? We noticed it did not factor. So we moved the C value that messed that up to the other side. We completed the square, and I did this. I should have written that better. We completed the square. Well, I totally left out the instructions there. We did it. We just didn't write it out. Complete the square. That's really number 3. And number 4, it's ready for the inverse function. Okay, let's do that again. Example 7. X squared minus 12x plus 3 equals 0. This does not factor. Factors of 3 do not add up to 12 or subtract to be 12. So 3 plus 1 is 4, 3 minus 1 is 2. Neither one help me factor this. So I need to get rid of this guy, move it to the right-hand side, leave a space. And when you leave that space, I like to put a square there. It reminds me I'm completing the square, and I can only add a square to the left-hand side if I do it to the right-hand side. I'm repeating a lot of stuff, and some of you get it, but some students have a hard time with this. So we're making this up. We're creating a situation that makes us solve this equation. So I'm going to say that this is 36 because x minus 6 is what would happen if I had x squared minus 12x plus 36 then it would be a perfect square trinomial, because x minus 6 times x minus 6 is x squared minus 12x plus 36. I'm also going to add 36 to this side and get 33. Square root, plus or minus, x minus 6 equals plus or minus the square root of 33. Put the 6 on the other side, it's positive, 6 plus or minus the square root of 33. This is the answer, and you leave it just like that. You don't need to find a decimal approximation. This is the most perfect answer you can have, and it's not rounded. It is the most exact answer you can have, leaving it in the square root of 33 form. One more, and then we're going to let you do some of your homework problems. So example 8, x squared minus 10x plus 7 equals, I'm going to say plus 7d equals 0. So there's my new equation. Factors of 70 do not subtract and make 10 or add and make 10. So what do I need to do? You try this one on your own, pause the video, come back and see what you get. Okay, x squared minus 10x equals negative 70. X minus 5 squared equals, I'm going to add, that pen's bad, so I'm going to add 25 and 25. Now I've got negative 70 plus 25, that's going to be negative 45. Yep. Now I take the square root of both sides, plus or minus, x minus 5 equals plus or minus the square root of negative 45. That does simplify. I'm going to write x equals 5 plus or minus the square root of negative 1 times 9 times 5. So that my final answer is 5 plus or minus. The 9 makes a 3 on the outside. The negative 1 makes an I, and the square root of 5 is left over. So you can even get imaginary answers, and that's why we did imaginary numbers before we did complete the square. So some of your homework is about you finding out what goes in this box. Some of the questions say find the C value. You're going to divide this by 2 and square it and get the C value. Some of the problems are probably already set up, ready to go, like example 4, so that you need to rewrite it as a square and then take the square root of both sides. Some of them, they ask you to do this and factor it, like example 4, we did both ways. And then some problems are actually completing the square, where you need to move the C value over that doesn't work, figure out what would make it a perfect square trinomial, and make sure to add it to both sides. That's the only thing that's fair in an equation. Then you take the square root of both sides and solve. All right, thank you very much. Complete the square. We're done.